Creatures of the day and monsters of the night, welcome. It's a beautiful night in the graveyard. I'm your host, Mortis, and I love photography. No pretense here, friends. Capturing the world in an image is one of the first things I did when I got my hands on a phone. They may make movie magic, but what's the science behind a camera? Cameras are all about capturing light. The first cameras were dark rooms or boxes with small holes to let in light. The light would cause film or photographic paper to react and darken, and you'd have a picture. Well, a negative, but you get the picture. There's an issue, though. If the pinhole is open all the time, our film will completely react, and the picture will turn out entirely white. We need a way to keep light from getting into our cameras, and thus, the shutter was born. By covering the pinhole until we want to take a picture, we can limit the amount of light that enters the camera. How long should the shutter stay open? Well, that's the shutter speed, and it depends on how much light there is in your scene. If it's a super sunny day, you might only need to keep the shutter open very briefly to get enough light for your picture. If you're in a dark indoor hallway, leaving the shutter open for longer can keep your picture from looking too dark. Shutter speed is measured in the number of seconds the shutter stays open, as a fraction, like 1/60. The trade-off is your ability to capture motion. If a subject moves while the shutter is open, the camera will observe it in multiple places, and your image will be blurry. Remember, fast shutter speeds for action shots. How wide should the shutter open? This is called the aperture, and it balances depth of field and brightness. We don't commonly use pinhole cameras anymore. Now, our cameras have lenses. Lenses focus light for a clearer picture and a wider depth of field, and the physics of where a lens projects this image gives us focal length. You'll see this value in the f-stop of a camera, which is inverse to the aperture size. A lower f-stop means a larger aperture, which will let in more light. The photo will have a shallower depth with far away objects looking blurry, but you might want to blur the background, so keep the aperture in your arsenal. Finally, digital cameras don't use film. Instead, they have millions of light-sensitive pixels that convert light into electrical impulses. How sensitive these pixels are is standardized through the International Organization for Standardization and is described using the so-called ISO value. Higher ISO values mean a camera is more reactive to light, so they're useful for dark environments. Being more sensitive to light also makes a shot grainier though, so it's another careful balance. In an extreme example, these two photos have ISO values of 100 and 1600 respectively. If the difference isn't clear, the left photo is much darker. It's almost entirely black. The camera was incredibly unresponsive to light in an already dark environment, and increasing the ISO value made the image much clearer. Pardon my example pictures being crime scenes. I have an unorthodox eye, perhaps. This new picture has the same ISO as the last, but a higher f-stop. That means a lower aperture, which is why the picture got darker. While my subjects weren't the most jittery bunch, here's a little demonstration on how shutter speed affects brightness. The picture on the left was taken with a slower shutter speed, so it took in more light. The slower shutter speed turned out brighter than the faster shutter speed, even with a difference of just 8 milliseconds. Shutter speed, aperture, and ISO are all carefully balanced to get the photo you want. Go out, grab a digicam, and take some fun shots. It's been a beautiful night in the graveyard, and this is Mortis, signing off.